Welcome, everyone. Today, we're diving into a critical topic in acid zinc plating: blisters. We'll explore what causes them, how to troubleshoot effectively, and practical solutions you can apply right away. This session is designed to give you clear insights and actionable steps to improve your plating process. Let's get started. To guide us through, we'll start by defining what blisters are and how they appear in zinc deposits. Then, we'll examine the unique characteristics of acid chloride zinc baths that influence blister formation. After that, we'll identify the root causes, followed by a systematic troubleshooting approach. Finally, we'll wrap up with prevention tips and best practices to keep blistering under control. So, what exactly are blisters in zinc plating? Essentially, they are raised bubbles or lifted areas on the zinc coating. They can be tiny, like pinheads, or large continuous lifts. Interestingly, they might show up right after plating or later during drying, chromating, or baking. You'll often find them in areas with high current density. These blisters signal issues like poor adhesion, weak boundary layers, trapped hydrogen, or organic inclusions. In other words, they point to process or chemistry problems that need fixing. Now, let's look at acid chloride zinc baths. They plate faster and with higher efficiency compared to alkaline systems, but they demand excellent cleaning since surface activation is limited. These baths are very sensitive to organic additives like brighteners and carriers. Too much or imbalance can cause stress and delayed blisters after baking. Iron contamination is another risk, as iron dissolves easily and can cause dark deposits and adhesion issues. Maintaining pH between 4.5 and 5.8, along with proper temperature and chemical levels, is crucial to minimize blistering. When it comes to blistering causes, three main areas stand out. First, inadequate pretreatment. Things like incomplete degreasing, overpickling, or poor rinsing can leave residues that lead to blisters. Second, excess brightener or organics can cause brittleness and delayed blisters, especially after baking. Third, bath chemistry issues such as low boric acid, low chloride, low temperature, or high iron content disrupt the plating balance. Recognizing these categories helps us target the right corrective actions. Addressing blisters requires a systematic approach. Start by fixing pretreatment. Verify cleaner strength, temperature, and timing. Control pickling carefully, and improve rinsing to prevent immersion copper. Next, check brightener and carrier levels using Hull cell tests, and treat excess organics with carbon or permanganate treatments. Then, analyze bath chemistry to maintain zinc, chloride, boric acid, pH, and temperature within recommended ranges. Finally, control iron and impurities through peroxide oxidation, filtration, and zinc dust treatments, ensuring continuous filtration is running. Let's talk practical remedies linked to specific causes. For poor cleaning, upgrading soak and electrocleaner cycles and using deionized final rinses can help. Excess brightener calls for carbon or potassium permanganate treatments and Hull cell confirmation. Low boric acid or chloride levels should be analyzed and restored promptly since they're known blister causes. Low bath temperature needs correction by raising it to the recommended range, avoiding cold starts. Iron contamination requires peroxide oxidation followed by filtration, and maintaining pH at the higher end helps slow iron uptake. Delayed blisters after baking usually point to excess organics or